Hi everyone, so we're going to be working through today Mock Set 2, paper 2H, the higher tier, calculator paper. Okay, so first question. So 100 adults were asked how they keep fit. Each adult goes to the gym, or runs, or cycles. 45 of these adults are female, 30 of the 52 adults who go to the gym are female, 35 adults run, 9 males cycle. How many females run? Now, because we're looking at kind of, well, two things here. We're kind of looking at, whether they're female or male, and then we're looking at whether they go to the gym, run, or cycle. What I'm going to use is a two-way table. So if I write down male, female, and then gym, run, or cycle. Because it says or as well, that makes me think I want to use a two-way table, because if they could be inclusive, so by that what I mean is if they could go to the gym and they could run, or they could go running and they could cycle, then I'd want to use a Venn diagram, because then you're going to have some overlapping. Okay, so just sketch out my two-way table. Right, then we can start to fill it in. So 100 adults were asked, or what I want to also have is total. So I'll put that in. Okay, so 100 adults were asked how they keep fit. So the total is 100. 45 of these adults are female, so 45 female, which means 55 male. 30 of the 52 adults who go to the gym, so 52 adults go to the gym. 30 of those are female, which means 22 are male. 35 adults run, so 35 adults run. Then I can work out how many are going to cycle. So I'm going to do 100, take away 35, take away 52 on my calculator, and I get 13. So 13 adults must cycle. 9 males cycle, so 9 goes here. 13 take away 9 is 4. And then I can work out these by doing 55. Take away 22, take away 9 is 24, and 45, take away 4, take away 30 is 11. Now look at what the question is asking me: how many females run? 11. Okay, and what I would just do as well is to check that all of my my columns and my rows add up to the totals they should do, because then you can be confident that you've done it right. Now some of them you would have worked out from the totals, but some of them you won't have done, for the rows and such. So make sure it all works. Then, like I say, you can be confident that you've got it right. 55 add 45 is 100. 52 add 35, add 13. Yep. Okay, good. So 11 females run. Question 2. On a school trip, the ratio of the number of teachers to the number of students is 1 to 15. The ratio of the number of male students to the number of female students is 7 to 5. Work out what percentage of all the people on the trip are female students. So what we need to do is, well, this is teachers, this is students. We need to split the students up into 12 parts, 7 parts and 5 parts, or a multiple thereof if you like. So if we can find an equivalent ratio of 1 to 15, where the 15, the multiple of 15, sorry, we can divide by 12. So if I start with 1 to 15, if I times them both by 2, I'm going to get 2 to 30. Now, teachers to students, I can't divide 15 by 12, can't divide 30 by 12, so let's go with 3 to 45, can't divide that by 12 yet. So 4 to 60. Now I can divide that by 12. So again, I'll write it over here. So teachers to students, 4 to 60. Now this 60, I can split up into, if I split it into 12 parts. So 60 divided by 12 is 5. So each part here is going to be 5. Times by 7 is 35. 5 times by 5 is 25. So that is male students. So male students and female students. Okay. Now if I combine all of that, I'm going to get 4 to 35. So teachers to male students to female students, 4 to 35 to 25. Okay. Now then I can use it to work out percentage. Work out what percentage of all the people on the trip are female students. So female students is 25 out of my total number of parts, which is 64, and then times 100. 25 over 64 times 100. It gives me 39%. Just give your answer correct to the nearest whole number. I've got 39.0625. Okay. Yeah, we need to basically combine the ratios, and you can't do that until you've got something like we've said, where I can split it into 725. Okay, so into 12 parts. So I need a multiple of 12. Okay, when you can do that, then I can split that 60 up into the 35 and 25, 7 to 5. Okay, and then I need to do percentage of all the people, so all of the parts that are out of all of the number of parts, so out of 64, how many parts are female students, which is 25 out of 64, and then times by 100. Okay, next one, constructions. So students at the school I'm working at haven't done constructions yet, so if you're watching this, which hopefully you will be over the next week, to see where you've gone right and where you haven't gone right, and where you need to improve, maybe, or where you're just looking for some answers on this test. You know, I'm not expecting us to be able to do this one because we haven't done it yet. In the space below, use a ruler and compasses to construct the perpendicular bisector of the line AB. Now, a perpendicular bisector, so it's going to be a right angle, and it's going to bisect it, which means cut it in half. It's going to go through the middle. Okay. Now the way to do that, this compass isn't the best. Actually, I need to tighten it up, so I'm going to be very careful with it. Ideally you want your compass to not move when you're using it. Okay, so I'm going to go with, I'm going to go with the length of the line, because that will be easy to make sure it stays that length. So what you need to do is, it doesn't matter what length it is, just make sure it is the same length and it stays that length. So we'll measure that. Now what I need to do is draw an arc. Okay. Now I'm just going to make sure that is about the same length. Yeah, it is. So my arc's going to go here. Now I need to do the same on the other side. So now move your compass point to the other end. Make sure it is the same distance. So that's why I'm going with the other end of the line. It's easier to measure. Now I need to do another arc. It's going to be quite high up on my paper. Now it's going to be, let me try that again. So I'll go back to my original point. Okay, match up that there. Now I need to do a curve. Now if my compass was more stable and stay where I wanted it to, I would do the full curve, but if I do that, I'm afraid it's going to move. So I need to basically get those two things crossing over, so I can just about see it now. It's just up there. It's a lot easier if you've got a good compass, as you can see. So yeah, it's crossing just here. Right, now I've done it above the line. I also need to do it down here below the line. So let's try this. It's a bit difficult, obviously, because my hand's in the way. I'll try and move it so you can see. So that's the same length as my line. So I'm going to move it down here, and I'm going to just make a curve like that. It's a bit easier. Put your point on the other end of the line. Again, make sure it's the same length as it was before, and do your curve again. So I can see there it's going to cross over quite nicely. Okay, I'm going to do the top bit again, because the bottom's a lot nicer and a lot easier to see. Right, so there we go. Now in hindsight I would have done a smaller distance so then I can see my curve better. Okay, now we've got 2 points where they cross over. So we've got this point here and we've got this point here. All we need to do is draw a line between them, and that should be the perpendicular bisector. Okay, so just get this pencil out of my compass. He says, there we go. So it's going to go from where those cross over down to where they crossed over below. And that's my perpendicular bisector. That'll be at a right angle to the line. Okay, and it will go through the middle. If I measure it, just to check. So just a bit below 7, okay, and it's about 7, and it goes through at 3.5. Okay, so it's a perpendicular bisector, that's how you do it. I'll go through it one more time, just really for those students that we're watching this back, that are at my school who want to know how to do this and haven't been shown before. Put your point on one end, make your compass a certain width, doesn't really matter which width as long as it stays the same. Okay, right, draw a curve, usually do the full curve if you need to. Put your point of your compass on the other end of your line. Okay, keep it the same distance apart, do another curve, make sure they cross over. Okay, do one above, do the same thing now below. So point on one end, keep your compass the same length, curve at the bottom. Swap over to the other side of the line, keep your compass the same length, again do a curve until it crosses over. Okay, then join up your 2 points where your curves have crossed. Okay, and that'll be your perpendicular bisector. Question 4. Okay, so here is the graph of x squared minus 2x minus 4. Write down estimates for the roots of x squared minus 2x minus 4. Okay, if you've got a graph, this is nice and easy. Just got to be careful with reading your axes. So it's here, that's one of them, that's another one. So that is negative 1.2. So x is equal to negative 1.2, or x is equal to that is 3.2. Okay, because that's 3.2. Write down the coordinates of the turning point. The turning point is this bit at the bottom here. That is going to be 1, negative 5, because it's right between negative 4 and negative 6. Okay, that's question 4 done. Question 5. The track has 2 straight sides, each of length 40. Okay, so that's 40 as well. Each end of the track is a semicircle of radius 27 meters. The diameter of each wheel of Ian's bike is 590 millimeters. Okay, so different units. So that's going to be 0.59 meters, because 1,000 millimeters in a meter. Ian is going to ride his bike around the track once. Calculate how many complete revolutions each wheel of his bike will make. Now, his front wheel and his back wheel will make the same number of revolutions, because presumably they're the same size, it doesn't say otherwise, and they're going to be going the same distance, so they should make the same number of revolutions, so we can discount that straight away. We just really need to think about one wheel. Now, what we need to figure out is the distance this track is, and then how many circumferences of his wheel will go into that, if you like. So we need to work out the circumference of this circle, so that's going to be pi times by the diameter to get the circumference. So pi times 27 times 2, radius times 2 gives me the diameter. So that is going to be 54 pi. Okay, so the distance of the track, so we'll put track length is 80, 40 plus 40 plus 54 pi. Okay, because that's a semicircle, so that's just one circumference, which is 54 pi. Okay, so that's part of the answer. That'll definitely get us some of the marks. Now we need to work out the circumference of the wheel, which is going to be pi times by the diameter is 0.59 times by 0.59. Okay, pi times 0.59 is 59 over 100 pi. We'll leave it as that. So 59 over 100 pi. So he's going to ride his bike around the track once. So we need to find out. This is going to be in meters squared as well, because sorry, not meters squared, meters, because it's a distance, and that's going to be in meters. Pi is not a unit. So we need to find out how many of these will fit into this. Okay, so we're going to do this divided by 59 over 100 pi. Okay, so I could write it as a fraction, but just because of the way it's... Actually, I will write it as a fraction, so over 59 over 100 pi. So the whole track divided by the circumference of the wheel. How many lengths of that wheel, because one rotation is basically the length of the wheel, how many lengths of that wheel will fit into the length of the track, and then thus that's how many revolutions it will make. And you want to know how many complete ones. So if it's like 0.8, we're going to forget the 0.8 and we're just going to go with the whole number part at the start. Okay, so fraction button, AT plus 54 pi, so the whole thing divided by 59 over 100 pi, and that gives us 134.7 to one decimal place. So our answer is 134 revolutions. Okay. Question 6. The front elevation and plan of a solid are shown on the grid. On the grid, draw the side elevation from the direction of the arrow. Now, if we have a look here, this is the plan view, so that's looking down. Plans, if you ever seen them for buildings, are top down. Okay, so like a bird's eye view. So that's what it looks like from the top. And obviously you can see these different heights or elevations here are separated out by these lines, so we're going to need to do that obviously as well if things are different heights for the side elevation. Now the side is from this view, okay, which again is going to be this view here, so it's that way. So what we're going to be doing is we're going to be looking at, basically it's going to be 2 squares wide, so 2 squares wide. Okay, now it goes up 1 square, and then it gets deeper, so we're going to show that by doing a line here, not doing it as a one solid rectangle, and then it goes up 1 square before it goes back again. And then it's going to go up 2 squares, so it's gone back, so you show that by drawing that line across, and then it goes up 2 more squares, and then again we draw the line at the top. So it looks like that, because obviously if you're looking directly from the side, you're not going to see, well, you shouldn't see if the lighting's perfect, which we're doing this as if it's a perfect scenario, no shadows. If you're looking straight at it, you're not going to see any there's going to be no angle to see that this really is a different height, other than the fact that we've got the top of this coming across, as shown here. Okay, and that's that question done. The distance from the Earth to the Sun is 1.496 times 10 to the power of 11 meters. The speed of light is 3 times 10 to the power of 8 meters per second. Show that, to correct 3 significant figures, light will take 0.139 hours to travel from the Sun to the Earth. Okay, to show that question, so we've got to be clear with our working out. Speed is distance over time. So that means we want time, so multiply by time, divide by speed. Time is equal to distance divided by speed. Okay, so what we need to do is we need to do the distance, 1.496 times 10 to the power of 11 divided by 3 times 10 to the power of 8, and plug that into our calculator. 1.496 times 10 to the power of 11 divided by 3 times 10 to the power of 8 gives me this, which is 498.6 recurring, which is definitely not 0.139. Now why is that? That's because this is number of seconds, okay? Because if I do meters divided by meters per second, that will give me my answer in time of seconds. So that's seconds. So now I need to do 498.6 recurring divided by 60. That'll give me the number of minutes. Divided by 60 gives me 8.31 recurring minutes. And then do 8.31 recurring divided by 60 to give me the number of hours. And that gives me 0.139 to the 3 significant figures. Okay, next question. 1 Google is 1 times 10 to the power of 100. Dinesh says when I multiply 1.496 times 10 to the power of 11 by 6.68 times 10 to the power of 9, I get nearly 1 Google because these two numbers multiplied together is 9.99 times 10 to the 99. Is Dinesh correct? No, he's not. What he has done is 1.496 times by 6.68 gives you 9.99 approximately. He's multiplied the powers instead of adding them. Because you're multiplying, you need to add the powers. No, he is not correct. He has multiplied the powers instead of adding them. It should be and then if we do it 1.496 times 6.68 gives 9.99328 times 10 to the power of 11 add 9 is 20. Question 8. Find an equation of the straight line with gradient 3 that passes through the point A. Well, it's got to go through the point A. Now I'm just going to check my axes here. So 1, 3, 5. Make sure these, well, make sure you know what they go up in. And it helps if you label each of them. Now, if it's got a gradient of 3, that means as my x increases by 1, my y increases by 3. So if I work backwards, as my x decreases by 1, my y is going to decrease by 3. So I'm going to get my next point here. So move left 1 again, I'm going to go down 3, so it's going to end up down here. Now this is going to have a gradient of 3, because as it goes to the right 1, it's going to go up 3. That's my line there, okay. Now, in terms of what the equation is, it's going to be, well, y is equal to 3x. 3 is my gradient, so that goes in front of my x, and then it goes through here at minus 1. Okay, so y is equal to 3x minus 1. That the bit you add or subtract is your y-intercept. Okay, so y equals 3x minus 1. And you can check that that does go through 2 and 5 by substituting in. 2 times 3 is 6, minus 1 is 5. Okay, question 9. Natalia pays £13,995 for a car. Lauren pays £14,495 for a car. Assume that the rate of depreciation for Natalia's car is 12% per annum, and the rate of depreciation for Lauren's car is 13% per annum. Per annum means per year. Work out whose car will have the greater value at the end of 3 years. Okay, so what we need to do is a bit of, well, repeated percentage change. So if we start off with Natalia, 13,995, and we're going to times that by 12% decrease. Depreciation means decrease. So a multiplier for 12% decrease is going to be 0.88, and it is going to be decreasing by 12% each year for 3 years, so that's to a power of 3. I'm going to work out my answer to that. So 13,995 times by 0.88 to the power of 3. 9537.20, and because it's money we're going to leave it to 2 decimal places. Okay, now that is Natalia, Now let's look at how much Laurens will cost. So 14,495 times by 13% depreciation, so 0.87, and again to the power of 3, and see how much or whose car will have a greater value. So 14,495 times by 0.87 to the power of 3. 9545.00, again 2 decimal places. So whose car will have the greater value? Laurens, just by about £8. Okay, a little bit less. So just need to answer the question, whose car will have greater value? Laurens' car will have greater value at the end of 3 years. Okay, the rate of depreciation assumed for Natalia's car was too low. Now that means if the rate of depreciation was too low, that means the rate of depreciation would be higher, which means it's going to be decreasing by more each year. So how does this affect the value of her car at the end of 3 years? Well, if it's decreasing by more, the value of the car is going to be lower. Okay, the value of the car will be lower. Okay, question 10. Okay, scattergraph shows information about 10 adult snakes of the same type. It shows the length and weight of each snake. An adult snake of this type has a weight of 740 grams. 740 is about here. Use the scattergraph to estimate the length of the snake. Well, to do that, I'm going to have to use a pencil and ruler to draw my line of best fit. So I can't go beyond these points here because that will be extrapolating the data. I don't really know what's going to happen up there. So I want to end up with approximately the same number of points on each side. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's about 5 each side. And if some are on the line, then that's fine. So let's go for about, we can go something like this. Now, obviously, if you're, we'll go, yes, that looks about right. We'll go like this. Now, obviously, some people's will be different, so there will be some leeway with your answer for this. There should be a, well, there will be a range. So an adult snake of this type has a weight of 740 grams. So 740 grams in between 720 and 760, halfway between. So I'm going to do a line across, and this is your working out. This is where the mark's going to come from, and then I'm going to go straight down. Okay, so it's about there. If I go down to my x-axis, I get a length of about 76. I'm going to go with, it's just a bit below, but it should be the 476. I haven't done my line quite where it should have been. Okay, I'm going to go with 76. Equally, I could possibly have gone for 75.5. You see, it's just, I'm going to make it so that it is on, because up here it looks like 76, and at the bottom it doesn't quite look like 76. So I want to get rid of any confusion or any uncertainty. So I'm going to go with 76 from my line there as being the length, my estimate of the length of the snake. So 76 centimeters. Okay, and again, there should be a range of values for that, because obviously everybody's line of best fit will be slightly different. Okay, and as you can see, like, I've got 1, 2, 3, 4, 5, 6 on one side, 1, 2, 3, 4 on the other side, but it's closer to those 6. It's a bit difficult because these are all on this side at least, they're all in quite a straight line. So it's either you get all of them on the line or you get none of them on the line, but you know, in my scenario it's closer, so it, you know, that's my line of best fit anyway. Everybody's will be different. Okay, question 11. Oh, sorry, 10b. Stephen wants to estimate the weight of an adult snake of length 110 centimeters. He says he will draw a line of best fit and read off the weight at 110 centimeters. Explain what is wrong with this method. Well, we went over this back here. Now 110 centimeters is up here, and we'd have to extrapolate the data. Now, our line wouldn't go 210 centimeters anyway, but we'd be extrapolating, which means we'd be going beyond the points we have data for, and we don't actually know what's going to happen there. So these heavier snakes, they might not be any longer. There might be a maximum length naturally of these snakes, and they might not be able to get any longer realistically than, say, 100 centimeters. So yeah, the point is we don't know what's going to happen after outside of the data points we have. So the data does not cover snakes with a length of 110 centimeters, with a length of 110 centimeters. So we would be extrapolating the data essentially. So we cannot use a line of best fit to estimate a line of best fit to estimate this. Okay. Next question, write this number in standard form. That's going to be 4.7805. Make sure you include all your non-zero digits. 4.7805 times by 10 to the power of 1, 2, 3, 4, 5, 6, 7. Just check that again. 1, 2, 3, 4, 5, 6, 7. Yeah, 4.7805 times 10 to the power 7. Factorise this. This is a difference of two squares. 121 is a square number. It's 11 squared. So that's going to be x plus 11, x minus 11. That's a special type of quadratic where it's got no x term and it's subtracting a square term. So that is going to be x plus the square root and then x minus the square root of this number. Okay, next question. Write down two things wrong with this box plot. Okay, now looking at our data here, the minimum, that's plotted correctly, that's at 12. Lower quartiles at 20. The median is not plotted right, that's plotted at 30. So median plotted incorrectly at 30 instead of 32. Okay, upper quartile, that's at 40, that's right. Now this point here, they put the range there. That shouldn't be the range, that should be the maximum value, in the same way that the bottom whisker is the minimum value. Okay, plotted maximum value as the range. Okay, so they plotted the maximum value as the range, slash, they could have also written it correctly in the table, sorry, incorrectly in the table, slash, written range in table instead of maximum. So it's one of those two things. Either this is plotted based on the range, which is wrong, that should be the maximum value, or they put range in here instead of maximum. So it's one of those two things. The range is largest take away smallest. Okay, and the interquartile range is upper quartile take away lower quartile. So the range would just tell us the difference between the lower quartile, sorry, the minimum and the maximum. So if we're to go by that, if that is the range, 12 add 55 is going to give us 67, so this should actually be plotted at 67, which obviously our axis doesn't go up to anyway. Okay, next question, simultaneous equations. Right, okay, now you can do these on certain calculators. So if you do have it's a Casio calculator. It's silver. I can't remember the name off the top of my head. It's about 25-ish pounds, but it can solve simultaneous equations like this for you. Okay, and then you can get the answers straight away, or at least check your answers with it. Okay, now in terms of the method, what we need to do is first of all label them. We then want to make it so that either the number in front of the x is the same, or the number in front of what the y's is the same. So I'm going to go with making. Let's go with making the numbers in front of y's the same. It doesn't really matter, or it doesn't matter at all which way you do it. But here I think it's easiest to make 6 and 5 into 30 than 4 and 7. I could make 28 out of those two. But I'm going to go with making the y values the same. So I'm going to do equation 1 times by 5. Okay, so 4 times 5 is 20x plus 6 times 5 is 30y equals 5 times 5, 25. Equation 2 times by 6. So that gives me 42x plus 30y is equal to negative 10.5 times by 6, which is negative 63. Okay, and I'm going to call these equations equation 3 and equation 4. Okay, now what I need to do, because I've got the same numbers in front of my y's, I'm actually going to subtract the two equations, because that will cancel out 30y, take away 30y, 0. So let's go with equation 4, take away equation 3. Doesn't matter again, but you've got to be careful about the negatives. I want to do 42 take away 20. 42 take away 20 is 22x. 30y take away 30y, 0. Negative 63 take away 25. So type that in my calculator, get negative 88. Okay, now if I divide both sides by 22, I'm going to get x is equal to negative 88 divided by 22 should give me negative 4, and it does. So that's one of my answers. That's x. Then I need to substitute x equals negative 4 into, and then any equation I like. I'm going to go with equation 1 because all the coefficients, all the numbers are positive. Okay, so substitute x equals negative 4 into equation 1. So 4 times by negative 4 plus 6y is equal to 5. That gives me negative 16 plus 6y is equal to 5. Add 16 to both sides, and I get 6y is equal to, that will give me 21, which doesn't look like it's going to give me a particularly nice number. So let me just double check that. 4 times by negative 4 plus 6y is equal to 5. Yep, 4 times negative 4 is negative 16. Plus 6y is equal to 5. Add 16 to both sides, and you get 6y is 21. So divide both sides now by 6. And we get y is equal to 21 divided by 6 is 3.5. Okay, or 7 over 2. So y is 3.5. Now when you've done that, what you need to do, if you have time that is to go back, substitute your values into any of the equations. So especially, well, you want to substitute them into the two they give you and make sure they work. So 4 times by negative 4, because x is negative 4, plus 6 times by 3.5. Now this should give me 5. If it does, happy days. It does. Okay, there you go. And I'm going to do the same with this equation, 7x plus 5y, and I should get negative 10.5. 7 times negative 4 plus 5 times 3.5, and I get negative 10.5. So I can be very confident now that those are the correct answers. Okay, question 15. Okay, prove algebraically that the difference between the squares of any two consecutive integers is always an odd number. Okay, so difference, so I'm subtracting between the squares, so I'm squaring something, of any two consecutive integers is always an odd number. Okay, now the key part there is consecutive, so I'm going to write at the start, let n be an integer. Okay, any integer. So we're doing the difference. So I want to do the bigger one, take away the smaller one. So the smaller one is going to be n, and then the one after that is going to be n plus 1. Okay, that's the next one after it, isn't it? And that's obviously going to be bigger because it's the one after. It's the number afterwards. Okay, so now I need to work this out. Now n plus 1 squared is n plus 1 times n plus 1 minus n squared. That gives me n times n is n squared, 1 times n is n, 1 times n is n, 1 times 1 is 1, minus n squared. Okay, now that gives me, subtract the n squared, I get 2n plus 1, and then that's essentially it. 2n plus 1 must be an odd number. 2n plus 1 must be an odd number for any integer n, therefore proven. Okay. Right, next question. Describe fully the single transformation that maps triangle M onto triangle N. So I'm going from this triangle to this triangle. Now, it looks like a rotation, but it's also been enlarged. Now, it's a single transformation, so it can't be a rotation then an enlargement. Okay, now what it could be, if it's an enlargement, we could have a negative enlargement, if you like. Okay, so it can be multiplied by something and the negative, if you like. So that is going to look like a rotation by 180. Okay, now I need to find the centre of rotation. I need to find also the scale factor. Scale factor is a bit easier. You can just look at the lengths. Centre of enlargement is going to be, well, not difficult, but we're going to have to do something. So I'm going to have to go from corresponding corners of each of the triangle. So from that top corner to this one. Okay, now I have to go from the other corresponding corner. So I'm going to go from this bottom right one okay, and then I'll do the last one here. So it's that corner to this corner. And where those lines cross is your centre of enlargement. So the single transformation is enlargement scale factor. Now we're going from M to N. Now it's gone from 4 to 8. Okay, but it's because it's gone, if you like, backwards through the centre of enlargement, it's going to be a negative scale factor. Okay, so it's gone from 4 to 8, so scale factor -2, centre of enlargement is this point here, which is 4, 6. There we go. Question 17. The diagram shows Helen's fish tank. The fish tank is in the shape of a cuboid. All dimensions are correct to the nearest centimetre. Okay, that makes me want to do the lower bound and upper bound straight away. So lower bound is 119.5. Upper bound is 120.5. 40. Lower bound is 39.5. Upper bound is 40.5. 70. Lower bound is 69.5 and the upper bound is 70.5. Okay, reading on, Helen is going to use a bucket to fill the fish tank completely with water. There are 14 litres correct to the nearest litre. So lower bound 13.5, upper bound 14.5 of water in a full bucket. With 25 full buckets of water, will 25 full buckets of water definitely fill the fish tank? Okay, so I need to make this the biggest possible volume it can be, and make the buckets the smallest possible volume, to make sure that it will definitely fill the fish tank. Okay, so we are going to do 120.5 times by 40.5 times by 70.5. So 120.5 on my calculator times by 40.5 times by 70.5, and that gives me 344,057.625 centimeters cubed. Now I also know that 1 litre is 1,000 centimeters cubed. Make sure you remember that, because that comes up pretty regularly. Okay, so that's one thing you need to make sure you know. Now if I change that into litres, so divide by 1,000, I get 344.057625 litres. Now if we use the lower bound for the buckets, so 13.5 times by 25 is equal to 337.5 litres. Okay, that's less than the maximum volume of the fish tank. So will 25 full buckets of water definitely fill the fish tank? No. 25 buckets of water will not definitely fill the fish tank, because if the fish tank is as big as it could possibly be and the bucket is as small as it could possibly be, then 25 buckets of water will not be enough. T is inversely proportional to the cube of U. Okay, now if T is inversely proportional to the cube of U, so that means T is proportional to inversely proportional to the cube of U, so 1 over U cubed. Okay, now that's because it's inversely proportional to the cube of U, so U cubed. That means that T is equal to something, K, constant of proportionality, times by 1 over U cubed, or K over U cubed, same thing. Now we need to substitute our values in and find a value for K, so T is 0.0096 is equal to K times by 1 over U cubed, which is 5 cubed. Okay, so that gives K times 1 over 125. What we need to do here is multiply both sides by 125, and that will give us 0.0096 times 125, 1.2. So 1.2 is equal to K times by 125. That will cancel out this fraction, so that will just disappear. So you get K times 1, which is K. So K is 1.2. Now from there, if we basically rewrite this first bit, or the second bit if you like, with K in there. So T is equal to 1.2 times by 1 over U cubed. Substitute our value for T in, so T is 0.15, so 0.15 is equal to 1.2 times by 1 over U cubed. Okay, now we're going to have to do a bit of rearranging here, which is a bit frustrating. So what we can do is, if we times both sides by U cubed, so times by U cubed on both sides, that gives me 0.15 U cubed is equal to 1.2 times 1. Divide by 0.15, and that gives us U cubed is equal to 1.2 divided by 0.15, 8. U cubed is equal to 8, which gives us that, well, the cube root of 8 is 2. Okay, so u is 2. Now I'll just show you another method to do that without the constant of proportionality. So if we have u here and t, if we say that u is 5, so use what we're given, and t is 0.0096. Now we want to get to when t is 0.15, so I need to work out what I need to multiply by. So on my calculator, 0.15 divided by 0.0096, that means I need to multiply by 15.625. Okay. Now, the difficulty here with this is because it's proportional to the cube of u. So what I need to get is not u, but I need to have u cubed. Okay, so I'll just go back. I get here 125. So if I put, let me change that to u cubed to make that 125 and put u over here. What do I multiply 0.096 by to get 0.15? It is going to be 125 over 8. So times by 125 over 8. Now because it's inversely proportional, I need to do the inverse operation, which is divide. So I need to divide by 125 over 8. So if I take 125 and divide by 125 over 8, I get 8. Now that is u cubed. So u cubed is 8 when t is 0.15, so that gives me u as being 2. Okay, so you can do it kind of using a table, just got to be careful obviously because of what I've written here, divide by 125 over 8. Now just be careful because it's proportional to the cube of u. Okay, so there's like an extra step there or an extra column in your table, and this was times by 125 over 8, so because it's inverse, you've got to do the inverse operation, divide by 125 over 8. Okay, and that will get you the 2 as well when you cube root the 8 to get the 2. Okay, that's just another method to do it. Okay, next question. By completing the square, find the coordinates of the turning point in the curve with this equation. You must show all your working. Okay, now if we complete the square here, we're going to halve the coefficient in front of the x. So x plus 5 all squared. Now if I expand that, I'm going to get x squared plus 5x plus 5x, so that's 10x, plus 25, and I don't want plus 25, so take that away. Okay, now I do want 18, so add 18 on. Now that will give me y is equal to x plus 5 squared minus 7. Minus 25 plus 18 is minus 7. Now it then says find the coordinates of the turning point. Now the turning point, or the lowest point, because this is a positive quadratic, it's going to be a U shape. It's going to be like this. So we're looking at the lowest point. Now the lowest point is going to occur when this bracket is 0, because if I square something, the smallest it can ever be is 0. So if I minimize that, then that will make this function the smallest it can possibly be. Okay, so to make that 0, x has to be negative 5. So negative 5 add 5 is 0, square it is 0. Now if this bracket is 0, then y is equal to 0 minus 7, which is negative 7. So my answer is going to be negative 5, negative 7. Okay, it's all about minimizing this bracket here, minimizing my square, making that equal to 0. So x is negative 5, and then if x is negative 5, y has got to be equal to negative 7. Okay, next question. A, B, C, and D are points on a circle. EDF is the tangent to the circle. Angle ADE is 54 degrees. Angle ABC is 114 degrees. Work out the size of angle CAD. You must give a reason for each stage of your working. Okay, so first thing I'm going to do, because this circle doesn't have a centre, I'm actually going to draw the centre on. So let's say it's there. Okay, roundabouts. Now, I'm going to use my ruler, and I'm going to draw a radius to each point here, A and C. Now, they have got to be equal, so because they're radii, Now, also what I want to do is I want to put these angles on here. So A, D, E. So that is this angle here. That is equal to 54 degrees. Okay, now what I also know actually from my circle theorems is that if I draw another radius here, my radius and my tangent are perpendicular, which means this angle in here has got to be 90 minus 54. So I need to write that down. I'm going to work it out. 90 minus 54 is 36. So that's 36. That's 36 because that's an isosceles triangle. These are both radii. And we need to work out CAD. So I just need to work out this angle now. Now, what I also know is that angle ABC is 114 degrees. That's 114 degrees. Okay, right, before we go any further, I'm going to start writing down to what I've done. So, angle, I'll call this O for origin. ODA is equal to 36 degrees as a radius meets a tangent at 90 degrees, and 90 subtract 54 is equal to 36. Okay. Then I also want to say that angle OAD is equal to 36 degrees as angles at the base of an isosceles triangle are equal. And then we've got the 114 on there. Now I can use that to work out what this full angle will be by opposite angles of a cyclic quadrilateral. Okay, so they've got to add up to 180. So that means angle ADC is equal to 180 take away 114 is equal to 66 degrees as opposite angles of a cyclic quadrilateral are equal. That means that this angle here has got to be 30. So angle CDO is equal to 30 degrees as 66 degrees subtract 36 degrees equals 30 degrees. That's not really using any other facts we know, just basically what we've worked out. So I don't need to put another kind of circle theorems fact there or angle fact there, because we just said that whole thing is 66. We've already said that's 36, so that must be 30. Okay, now There are other ways you can do this, but because I've worked out that's 66, I can work out this angle here from the 54 by alternate segment theorem. So that is going to be also 54. Now, that means I didn't actually have to work out that 36 in the first place, but it doesn't matter. Sometimes this is how it works. So, you know, essentially work out as many angles as you can, and that will do it. Now, obviously, I could have done this another way, and the way that I could have done it is use this angle here to then say that the angle at the center is double the angle at the circumference, so that would be 228. Now that means, so I'm talking about this angle here, that's 228 because it's double the angle at the center. Now that means that the inside angle here is 360, take away 228, which is 132. Now we've got another isosceles triangle, which means we can work out this angle. Okay, so 132, so 180 minus 132, and then half it divided by 2 is 24. So I make that 24, which would make my answer 24 add 36, 60. Makes that 60. Now we're going to see if I do this the other way, which is the way I spoke about just before that, that we do also get the answer of 60. So the way that I just noticed, we know this adds up to 66 using alternate segment theorem. Angle DCA is equal to 54 degrees as angles in alternate segments of a circle are equal. Okay, so that means that this angle here, that whole angle is 54, and then angle CAD, which is the one we want, is equal to 180 subtract 54 subtract 66, which equals 180 minus 54 minus 66, 60 degrees. Okay, as angles in a triangle add up to 180 degrees. So there's different ways you could have done that, and I've used quite a lot of angle facts there. I've worked out a couple of angles. Well, I worked out one angle I didn't need to, a couple really. I worked out that angle I didn't need to, and that angle that in hindsight I didn't need to, but it doesn't matter. Okay, next question. Question 21. Okay, find g of f of 4. And what I think helps with this is if I put brackets around the f of 4, that tells me I need to do that bit first and plug my answer into g. So f of 4 is equal to 3 times 4 squared, which is equal to 3 times by 16, which is 48. Let's double check that on my calculator. 48. Now I need to plug that into g. So g of 48 is going to be 1 over 48 minus 2, which is equal to 1 over 46. Again, double check it on my calculator to make sure I haven't made any silly mistakes. No, so there we go. It does say give our answer as a fraction as well. Okay, next question. Another straightforward one, I would say, for being at the end of the paper. I'm just trying to move it to get the camera to focus. A plus root 8 squared. Now, I know root 8, because I've come across it many a time, is 2 root 2. And we're going to square it. Okay, find in terms of A an expression for C and an expression for D. So, I'm going to square that, so that's A plus 2 root 2 times by A plus 2 root 2. A times A is A squared, plus 2 root 2 times A is 2A root 2. A times 2 root 2 is 2A root 2. And then 2 root 2 times 2 root 2. 2 times 2 is 4. Root 2 times root 2 is 2, so that's 4 times 2. So that gives A squared plus 4 times 2 is 8. Plus 2A add 2A is 4A root 2. Okay, so C, which is my constant term, my number term, is going to be this bit. So that's C. And then D is going to be 4A. So C is A squared plus 8, and D is 4A. Okay. Yeah. Next question. Question 23. Nearly finished. Show that this equation has a solution between 0 and 1. So what we need to do is we need to substitute in 0 and 1 and show there's been a change of sign. So 2 lots of 0 cubed plus 4 lots of 0. I actually need to rearrange this first of all. Minus 3. So I'm just going to rearrange this over the top. So 2. I didn't realise it wasn't. I didn't realise it wasn't equal to 0. So plus 4x minus 3 from both sides is equal to 0. Okay. So again, so like I said, plug in 0, plug in 1. If it's got a solution between them, then this will give me positive values and negative. Well, one will give me positive, one will give me a negative, which means that it's been a change of sign. Okay, change of sign means there must be a solution in between because our graph must cross the axis in between, which means there's a root. So 2 times 0 is 0, 4 times 0 is 0, minus 3 is minus 3. So 2 times by 1 cubed plus 4 lots of 1 minus 3. That's equal to 1 cubed is 1, times by 2 is 2, plus 4 lots of 1, which is 4, so 2 add 4 is 6, take away 3 is 3. As there is a change of sign between x equals 0 and x equals 1, there must be a solution to 2x cubed plus 4x minus 3 between 0 and 1, and thus a solution to 2x cubed plus 4x is equal to 3 between x equals 0 and x equals 1. Okay, because it's just a rearranged form. So if there's a solution to this, then there must be a solution to this. Okay. Right, show that we can rearrange this to this. Now, what we've got here is, if I have a look, I've got 4 on the bottom of one of my fractions, so I think I've divided by 4 somewhere here, and I've also got an x cubed, so I haven't changed that. So I think what I'm going to do, obviously I'll write down what I start off with, 4x equal to 3. I'm going to take away 2x cubed from both sides. So take away 2x cubed from both sides. And that gives me 4x is equal to 3, subtract 2x cubed, and then I'm going to divide by that 4 to get x equals. X is equal to 3 divided by 4, make sure you divide everything by 4, minus 2 divided by 4, which is a half, so that's just going to be x cubed over 2. Okay, done. Wasn't that difficult, and obviously it's 1 mark, so it shouldn't be. Okay, starting with x0 equals 0, use this formula 3 times, find an estimate, the solution to this. So x0 equals 0, x1 is equal to 3/4 minus x0 cubed over 2, which is equal to 3/4 minus 0 cubed over, sorry, not 4, 2. So that's going to be 3/4, because 3/4 minus 0 cubed is 0. X2 is equal to 3/4 minus x1 cubed over 2, which is equal to 3/4 minus 3/4 cubed over 2. I have to put that into my calculator. Now, the best way to do this on your calculator, people, is type in your first one, so 0. That's now my answer. So now what I need to do is 3/4 minus fraction, answer cubed divided by 2. That gives me 3/4. So that's x1, which is what I've got. Now x2, press equals again, it'll put my 3/4 up there. So I get 69 over 128. I'll leave it as a fraction for the moment. Okay, right, and then x3 is going to be 3/4 minus x2 cubed over 2, which is 3/4 minus 69 over 128 cubed over 2. And again, just press equals on my calculator. There we go. And I get the next one, which is 0.671. It doesn't say what to round this to, so I'm going to go to 3 decimal places or 3 significant figures. So 0.672, 3 significant figures. Okay. Now, obviously, what you can do when you've got that is, if I keep pressing equals again and again and again, it should get closer and closer to the solution. So just keep pressing it. Sometimes you get ones that jump backwards and forwards, which might happen, might not. And sometimes they take a long time to get close, and sometimes they can do it very quickly. So I can see that that is pretty close. It's not changing the first 5, 6 decimal places. It's only changing these end ones now. So if I keep going to it, it doesn't change anymore, which is very close to. Yeah, so that's not changing anymore now. So that is, or should be, a solution now to this equation. So if I now type that in, so if I do 2 times answer cubed plus 4 times answer, it should be very, very close to, if not 3. Yes, there we go. Okay, so that's as close as my calculator we get able to get to the solution. Okay, so I know that is very close, and I have applied it 3 times. 1, 2, 3. It says 3 times. Okay, next question. Okay, question 24, penultimate question. The area of this triangle is 42 centimeters squared. Find the length of AB. So you need to find the length of this side here. Now, I've got a side, I've got an angle. I don't know perpendicular height, or I don't know the perpendicular length from that base there, so I can't work out the area that way. But the other way I know to find out the area is a half AB sine C. So if I do a half times by BC times by 7 times by sine C, so sine 70, that has to give me the area, and that is 42. So now I can do something to rearrange that. Well, let's work out what, let's have a calculator on, that will help. A half times by 7 times by sine 70, make sure you calculate it in degrees with a D at the top there, gives me this awful number. Oh, that is a bit awful. So that gives me that. What I could do instead is, if I do 42 divided by this, that will give me BC. So BC times 7 times sine 70, I times both sides by 2, equals 84. Divide by 7, so BC divide by 7 here. Got to do a bit of rearranging. Divide by 7. BC times by sine 70 is equal to 84 divided by 7, which is 12. So BC is equal to, divide by now sine 70 on both sides, 12 over sine 70. Okay, I'll try BC over here so it's a bit closer. So BC is equal to 12 over sine 70. Okay, now I'll just keep that as it is, because this will give me a horrible looking decimal thing which I don't really particularly want. But we'll just check it does. I mean, it will do, because sine 70 isn't anything particularly nice. So it gives me this, about 12.77. Now I could write that down, but if I use that I'm going to get a rounding error, so I don't want to use that. Okay. Now, that's going to give me here 12 over sine 70. Okay, now I've got one side there, one side there. How's that help me? Right, I'm also going to write down the cosine rule because that could help me as well. So, a squared equals b squared plus c squared minus 2bc cos a, where that is the angle there. Now, what I can then use, I was thinking about sine rule before, but sine rule is opposite angles and opposite sides, so that's not particularly going to help me. 'Cause I can't work out any of these angles here. What I could use, however, if I say this is A, let that be B, let this be C, and then that's obviously going to be capital A, I can use this formula. So A squared is equal to B squared, which is 12 over sine 70 squared, plus C squared, which is 7 squared, minus 2 times by B, which is 12 over sine 70, times by C, which is 7, times by cos 70. That will give me A squared. If I type that into my calculator, then all I've got to do is square root it. Okay, so calculator. Try and get it where we can see it. Let me move that up. So, 12 over sine 70 squared plus 7 squared minus 2 times by brackets 12 over sine 70 times by 7 times by cos of 70 equals this thing. So 150.929 dot dot dot. And then I need to square root that. So A is equal to the square root answer 12.28, and I want the 3 significant figures, so that's 12.3 to 3 significant figures. Okay, there we go. So we're going to have to remember cosine rule and potentially sine rule and half AB sine C. A bit of a tricky question, that one. Okay, final question. There are some red counters and some white counters in a bag. At the start, 7 of the counters are red, the rest of the counters are white. Okay, Alfie takes at random a counter from the bag. He does not put the counter back in the bag, okay, so it's without replacement. Alfie then takes at random another counter from the bag. The probability that the first counter Alfie takes is white and the second counter Alfie takes is red is 21 over 80. Work out the number of white counters in the bag at the start. So I'm going to do a tree diagram. Okay, now we've got red counters and we've got white counters. Red, white, red, white. Now the only way we are worried about is the first counter Alfie takes is white, so we're going down here, and the second counter Alfie takes is red. Okay, so we're only worried about those branches, that one and that one. So the probability takes a white counter with 7 counters that are red. Okay, so let's let x be the number of white counters okay, then the probability takes a white one out is going to be x over how many counters he's got, which is x plus 7. Okay, now if he then takes a red one out, if he's taken a white one out, the number of reds hasn't changed, which means there's still 7 reds in the bag out of what's going to be 1 less than x plus 7, which is x plus 6. He's taken 1 counter out, so it's 1 less. So this is the number of white counters, add the number of red counters. The red counters haven't changed, but the white counters have gone from x to x minus 1. X minus 1 plus 7 is x plus 6. Okay, now I know if we times these together, because if I go along my branches I've got to times them, so x over x plus 7 times by 7 over x plus 6 has got to be equal to 21 over 80. Okay, so that gives me 7x over x plus 7, x plus 6 is equal to 21 over 80. Now, I'm just going to go up here a little bit to use more space. If I multiply both sides by 80, I'm going to get 80 times by 7, which is 560, x, and that's got to be equal to 21 lots of this quadratic. So 21 lots of x plus 7, x plus 6. Why is that really small just to fit it in? Now, that gives me 560x is equal to 21 lots of, expanding this, I get x squared plus 7x plus 6x, which is plus 13x plus 42, 7 times 6. So I then get 560x is equal to 21x squared, 13 times 21 is 273, plus 273x, 42 times 21 is 882, plus 882. This is looking pretty awful at the minute. Okay, now I need to take away 560x from both sides. So 0 is equal to 21x squared. 273 take away 560. 273x take away 560 is minus or negative 287x plus 882. Now that is pretty awful looking. So what I'm going to do is I'm just going to use a quadratic formula. Okay, and again I'm going to get it somewhere we can see a calculator. So quadratic formula, don't need that. Fraction button, it's minus b. So that is going to be minus negative 287. And then we've got plus or minus the square root of b squared. So b is negative 287 squared minus 4 times by, a, which is 21, times by c, which is 882, all divided by 2a, which is 2 times 21. Press equals, and we get 9. So x equals 9, or change that plus here to a minus, and we get 14 over 3, which isn't possible. So it's right here, not possible. Okay. So the number of counters that must have been in the bag at the start, the number of white counters must have been 9. I'm just going to put here as well, by calculator with quadratic formula. So actually I'll write down my quadratic formula. So I'll write down what I typed in. Now some calculators can solve quadratics automatically. So if you use that, just write down by calculator. But I would always, if you can remember it, write down the quadratic formula, because I don't think you'll get the marks for writing by calculator if you make a mistake. So if you type something in wrong, okay. So I'll just write that down. Negative 287 plus or minus the square root of negative 287 squared. Minus 4 times by 21 times 882 all over 2 times by 21. Okay, that's my quadratic formula there. So work out the number of white counters. Number of white counters is 9. Okay. Right, hopefully people, that is the end of the paper, isn't it? I mean, hopefully that's the end of the paper, that is the end of the paper. Hopefully that was useful. If you found it useful, you know, as always, please like and subscribe for more videos. As I've said previously, I'm making one of these videos on one of these mock set papers every 2 weeks and going through them for you. Okay, thank you, and bye-bye.